So today we've got to finish a bit more revision with probability, and then we're doing 7.3 and 4 straight after that. So we're heading into a thing called multi-stage experiments. So with a die, sometimes you're being asked to roll it a number of times and recording your observations. So in roulette, it's two dice, but they're rolled actually at the same time. Sometimes they're rolled at the same time. Sometimes they're rolled or flipped one after the other. So you just got to be comfortable with that sort of thing. You find the probability that when a coin is tossed 3 times, and we want to find the probability that one head is observed. So one way is to organize your outcomes as a tree diagram. So does anyone know how would we construct a tree diagram based on tossing heads and tails 3 times? Did you do many tree diagrams back in the day? Okay, when you were a little bit younger. Okay. So the first time round is the first flip. And like any tree, they have branches. That's the second flip. And once again, the third. Now, this is only useful with a small amount of trials. You're going to be doing probability when there's hundreds and hundreds and hundreds of trials. Guess what? This isn't going to help you if you're going to do hundreds of times. You're going to end up with a really big tree, and that's going to take too much time. So there's other techniques that you need to use. So therefore, it's just like a highway, and we're traveling from the start to the finish. These are all finishes, and the first one, we could possibly get 3 heads in a row. And you just simply keep branching out to the next thing. So to get to T, we've got to HHT. HTH. HTT. Have I missed one? No. THH. THT. TTH. And last one is a T, T, T. Okay. So one head is observed. I'm only interested in one head. Remember, that's the event that we're interested in. In the bracket is what you're focusing on. Okay. If I want to get the probability of one head only, probability is a language topic predominantly. One head is one head only. How many times out of these total bay combinations can we get one head? Let's say one head.
Why does it say TT?
Oh, sorry. Thank you. TTT. Thank you. One head only. All right. There's 3.
Yeah. Right.
Out of the 8 options. Okay. So as I say, look, it's 1, 2, and 3. Okay. What if I asked for 2 heads? Okay. How many, Jesse? Would I get 2 heads?
2.
2? There's 1, 2, and 3. That's all right. And at least 2 heads. At least 2. Okay, there's 4. 4 out of 8. As I said, always cancel and simplify. Okay. Any questions with that? So coins are pretty easy when you're tossing a small amount of times. But sorry, if you don't get tell me a better way to scroll, let me know. Next question, find the probability that when 2 dice are rolled, that the sum of the numbers is greater than 10. Now, you could do this. You could do a tree diagram. But what's another option? You could start off as 1, 2, 3, 4, 5, 6. You could do that. But for each of those ends, what would we need to do, Nathan? If we're tossing twice. How many branches on this one here? Not 2. Okay. There'll be not 4. More. There'll be 6. Okay. It's getting a bit messy. So if you look on the screen, I prepped one earlier. You can do tree diagrams. Or you can do grids. First roll, 1 to 6. Second roll, 1 to 6, and you combine them. I can roll a 1 and a 1, 1, 1, 2 and a 1, 2, 1, all the way down to 6, 6. Okay? But that doesn't answer the question. The question is, we want to find out the probability that the sum of those two numbers is greater than 10. How many of those combinations, those outcomes in the middle, is greater than 10? There's 6. Okay? We know from 6, 4, that's greater than 10, we don't count it. So 1, 2, 3, 4. 1, 2, 3, 4. So 6. Greater than 10.
I thought it was greater than 10.
Okay. There's 4. I think I did a mistake on my notes. 1. Yeah, that's right. I've got a mistake on my notes. There should only be 4.
Wait, no, greater because 5 plus 5 is 10.
Yeah, 5 and 5 is 10. 10, 10, 10. So 1, 2, and 3 are only. I'm going to have to put a correction on my notes. 3 out of 36. 3 out of 36 is that 3 out of 36 is what? 1 out of 12. Okay. Make that correction later. Any questions with that? So that's all wrong in there. Fix that up. Okay. Let's start combining things. Okay. 50 people were questioned on what social platforms they were using online. Total 26 said they used Instagram. Who uses Instagram here? Hands up. Okay. Who's on TikTok? Okay. Who does both? Okay. Anyone do Facebook here? Facebook. Okay. I don't really use Instagram or TikTok. I'm a Facebook guy, just to buy and sell, and just of the 18 who use Instagram, 11 said they also use TikTok. Show this information on a Venn diagram. So I noticed over the last few years, I've been addicted to my phone, including Facebook and Marketplace. And so I decided to make a life change. My phone, I have a dumb phone. I don't have an iPhone anymore. This is my phone. Okay, it's called a light phone. You can only call people and text people. And there's some other functions in there. And it allows me to just not get distracted. So how many people use TikTok but not Instagram? We're gonna demonstrate this on a Venn diagram. All right. How many circles do we need for this one here? Okay, 2. Okay, what are we going to name these circles, Harry? Harry, what letter would you use? Okay, TikTok and Instagram. Now, it's really important as well. You can label outside this outside space. What is the outside space? The universe, the universal set. Okay, so that's on the outside. All right. So we need to punch in some numbers here. It says a total of 26 said they use Instagram, TikTok, or both. Of the 18 who use Instagram, 11 said they also use TikTok. So what's the first number that we can put, Maya? Where would you put your 11? In the middle. Okay. And then we've got to fill it all the way from here. So what can I put in the Instagram knowing that there's 11 already there? 7. Thank you, Tim. Because we've got to get to 18. Okay. What else can we fill in? A total of 26, they used Instagram, TikTok, or both. Of the 18 who used Instagram, 11 said they also used TikTok. Share this information. Can we, anything else here? We can put 8 in TikTok. Okay. Got that? Why is it 8? Because we've got to get to 26 for a total of both. Okay. What am I missing? The universal set. We need an outside group of people to finish this question off. How many are on the outside, Amy? If there's 26 that are using in here, 24. Okay, so there's 24 on the outside. It is a fact that there are people who exist in the world that do not use Instagram and do not use TikTok. Now, look at the question carefully. It says how many? How many people use TikTok but not Instagram? Are we finding a number or are we finding a probability? We're not. Okay. How many? Yeah. So just be careful. We'll eventually calculate probabilities. How do I write this sentence using just letters in a bracket? What could I put in there? How would I describe it in short without writing it in words in this space here? Okay. Do I want TikTok? Yes. What don't I want? When you don't want something, you put a dash. That's not Instagram. And when you combine things, they're an intersection. This is an intersection. And we know, so we want T but not I. So for example, what's happening here? It's going to get a bit messy. We want T, that's all of T. But we don't want anyone to do with I, so they go. So we're left with 8. Okay, what does this mean? What's the answer to this one here? Using our Venn diagram. Sorry, 24. We do not want any TikTok users or Instagram users. There might be other type of users. They're on the outside. Okay. Next question. Now we're going to get into probabilities. Okay. What is the probability that a student chosen at random from this group of 50 use TikTok and not Instagram? Okay. TikTok probability now. TikTok and not Instagram. Anyone got a number for me? 8. Which was the same answer as before, but what's changed? What needs to change here? Divided by 50. You must answer the question. There's a difference between how many and the probability. And that's a 4 out of 25. And I've got a mistake in my notes. Okay. What's the probability that use neither? Once again, get an answer from before. It's 24 out of 50. Make sure you simplify. Okay. Last. Let's see. No, it's not the last. Sorry, guys. Okay, I have something on the TV called the addition rule. And that right there, I've got a version of the addition rule as how many. I've also got a version of the probability of the addition rule in a probability version. For one lolly, can you explain why this equation is what it is? Sorry, Tim? Are both. They're both versions of the same thing. Can someone try and articulate in your own words what the addition rule is?
It's like A, it's like A as well.
Okay, so what's the problem, Tim? Just the middle part, okay? Does anyone else want to explain in your own words in addition to Tim? Okay. Is there a basketball game going on? No. Is the finals are on? Okay. Anyway, when we add things together, if I count I, and then count T, you're counting twice. So don't count twice. This rule says that if I add a and B, I've got to take away one of the recounts in the middle to get back to the actual number. Because when you add the two circles, you're actually counting the middle part twice. Okay, so let's just apply this. So we're gonna use, not gonna go with that. If I want to calculate I UT, what does this stand for? What's the word? It's union. This is when you're not looking at what's common. You're gathering everything together. You're marrying two. So, like when I got married on the holidays, I don't just do what's in common with my wife. It's now I have a life outside of my wife that she needs to engage with as well, in a way. Okay? So, a union. What would, if we were to use that equation on the bottom, we break it up, you can sort of know what the answer is anyway. You add your two things, your two circles together, but we're going to minus the in-between because that allows us not to count the middle twice. That equation is usually on your formula sheet. But if you get it without the formula, you don't need to use it. But let's use it. Probability of I. What should I put in here? 17? 18. Thank you. Good correction. Probability of T, Amrita. Probability of T.
Yes, T.
All of T. 19. 19, 50. Now we're going to subtract here. Okay, Hudson, what's this here? I with intersection T. What's common? What's the number that represents this? 11. Okay. You get a total 26 out of 50. If I'm right, it's 13 out of 25. All right. Any questions? We'll do one more example, then we'll take a break, like for a couple minutes, and then we'll go again before, hopefully before period 4. Okay. Okay, Tony's going to McDonald's to have dinner. Probability that he'll order Big Mac is 0.37. Probability that he'll order McNuggets is 0.5. And the probability he will order both is 0.12. Okay, he goes to McDonald's here. Jesse, what do you normally order? It's okay, you can be honest. No judgment here.
I get a lot.
A lot? What's a lot?
What else you get nuggets,
Nuggets?
chicken and cheese, and a
Chicken and cheese person.
quarter pounder,
Nice.
with fries and a drink.
Great. That's good. Who has something different? I'll be honest, I do like my McDonald's. I don't eat it too much though. I used to eat it every week when I had faster metabolism. When you get older, you'll notice when you eat, um, things slow down. You're going to put on a bit more weight. So just be mindful of that when you get older. I like to have a Big Mac meal with 10 nuggets. Okay.
Oh.
So, Carno map, I think. Two things happening here. Big Mac, no Big Mac. Nuggets, nuggets, no nuggets. Be nice and neat. Don't be me. Use a ruler. You'll need some totals on each end. All right, we've got a few values here that we need to punch in. What's the first thing that you're going to put down? Would you put down? Emily, what would you put down? Okay, what do you put down first?
So Big Mac, but not nuggets, so 0.37, so you can put that in.
Down here?
Yeah.
Thank you. 0.37 goes there. And the one above it? In the total?
You put it on the right.
Oh, did I? Oh, I did. We'll go through it, one. Unless I've made a mistake. We'll work it out. It's okay. Point. I think I'm right. Okay.
That's right.
Yeah. Let's go. Let's go for it, and then we'll reflect. 0.12. Where am I going to put a 0.12? Which box?
The top left.
Top left, correct. If I have 0.12, 0.37, a 0.25, got to use your subtraction. Okay. Where am I going to put a 0.5? The top right, this one or this one? This one? And the total. What's our magic number at the end of the Carnot map?
1.
It's a 1. If it's a 0.5 here and a 1 here, Perry, what goes in here? Very good. If a 0.5 here and a 0.12 here, Hudson, 0.12? Point? Not quite. This is 0.50.
Oh.
And a 0.12. Think of it that way. Very good. 0.38. This is a 0.50. What goes in here, Rita? The 0.25. Nathan, what goes there? Here? 0.63. These two add to 0.63. These two add to 1. It's all going to match up. Almost done before our break. Probability. We don't want a Big Mac. Tony just wants nuggets today. He's already had lunch. He's my friend from the other. He was actually my best man. Yes. Not Big Mac and nuggets. Which number would you pull from the table? A 0.38. 0.38 here. Not Big Mac and nuggets. They combine. Let's go to the next one. Probability. Neither. He might have a chicken and cheese like Jesse. Neither. Which one is neither? 0.25. Thank you, Rita. I don't want a Big Mac. Tony doesn't want Big Mac. Tony doesn't want nuggets. 0.25 in here. Okay. You can do it that way too. Now, last question. Probability. This is not a bun. I know that there are buns in the Big Mac, yes. But this is B union with N. B union with N. Does anyone have an answer straight away? Do you need to put it on paper? When you're stuck, this is a bit. It's not one. It's a bit tricky. Tim is right. It's 0.75. Okay. Remember, what rule is this? The additional rule. You add B, add N, but you take away the double count, one of the counts anyway. Okay? So this is where the equation can help you if you can't visualize it like a Venn diagram. Probability of B is 0.37. Probability of N is 0.5. These are the totals. But we must take away is 0.12. Because in here, that's the double count. When you do it in a Venn diagram, that's the double count. You've got to get rid of it. And as Tim said, it's 0.75. Okay? Any questions with that?
Yes.